Okay, so I'm up first, and my project is the fireball shooters. So I really like the Harry Potter movies, and I've done quite a few of the props from it. If you'll remember, one of the first props we ever did was a spider drop where it plays music from Harry Potter, and then the spider slowly descends on you. And this time, I really wanted to do something with that dragon. The dragons in Harry Potter are really kind of cool, and that horntail is just one cool piece of work. So I wanted a dragon, but I wanted to shoot fire. And so this is kind of the project I came up with. And next slide, please. There we go. Okay. So my initial thought was I really liked the vortex cannon that the King of Random channel on YouTube put out. It was really cool. It can shoot a ring of smoke up to 30 feet. And I thought, well, that's cool. I'd like to shoot the ring of smoke, but maybe I could even do one better than that and actually shoot, some stoichiometric correct propane that gets ignited and is burning along the way. And I experimented with it a bit. I had a really hard time getting the stoichiometric mixture. The big reason for that is the methane is very heavy compared to air, and you kind of have to get it mixed together in order for it to actually work the way you think. And I might revisit it. I might add it to what I have now at one point in time, but I kind of abandoned that for something simpler. So what did I abandon it for? Nitrocellulose. So nitrocellulose is just the fancy name for, it's also known as a gun cotton or flash paper. And what it is it's nitrated cellulose. And as you know, sorry, my chemistry straight. Nitrates burn really well. So we're actually changing the chemical composition a little bit in order to, of cotton in order to get it to burn more rapidly. So it's a pretty straightforward process. Basically, you have your cellulose, which in this case is cotton. You can also use anything that's 100% cotton as well. So if you had like a t-shirt that was 100% cotton, you could use pieces of it and make it. And certain papers. There's a caveat though, and I didn't get to add this to my slides, didn't quite have time. I think the cellulose has to have a bit of endurance. So I tried to do a piece of cardboard, for example, and the cardboard basically combusted in my flask of acid. So I don't think the cardboard had enough molecular cohesion to survive the process. But what you do is essentially you take equal parts of nitric acid, and it has to be technical grade nitric acid, and pretty pure sulfuric acid, 97%. You mix equal quantities together in an ice bath. You throw a dozen or so cotton balls into the mix. Every 15 minutes, tamping it down with a glass rod, making sure you use a glass beaker, of course. Oops, wasn't ready for that. Okay, sorry, 1 second. Laser pointer, okay. Making sure a glass beaker, and then just a glass rod as well, because anything else would probably get eaten. And then just every once in a while, just kind of tamp it down a little bit, make sure that acid's getting in and out of those cotton balls. And then when you're done, all we have to do is rinse it out. So what I did is I just had successive solutions of water. So I put it in the first solution and then tamp it out. Oh, geez, sorry about that. Well, there's nothing I can do about it, huh? Okay, sorry about that. Anyway, so yeah, in the first solution of water, it's pure water, but then you tamp out the acid and it becomes pretty acidic water. So then you take it out of that water and you put it in another water and you tamp it a little bit more, and it's a lot more clean. And then when you're done, you want to get all the acid out as you can. If you allow some of the acid to stay, one, it doesn't burn as cleanly, and two, it burns with a really acidic smell and probably a harmful smell. So you want to make sure you get all of the acid out. But beyond that, after you've let it sit in there for about an hour and you rinsed out all the chemicals, you just have to get it completely dry. The instructions I used suggested using a hot plate on the lowest setting. And so I had a hot plate and I had it on, and it was about 130 degrees on the surface. And I had bits of it start to spontaneously combust. So I don't recommend using a hot plate at all. Just let it dry in a dark, warm place. But this is a piece that I made. It's actually sitting on my desk right now still from the picture. And it looks exactly like a regular piece of cotton when you're done. Throughout the process, it looks a bit yellow, but once you're done, it's pure and white as regular cotton. So I was going to put a video of me making some nitrocellulose in here. I didn't get that done in my slides, so sorry. But here's the parts I have. I need to for this build. I need a pneumatic valve. So I found this just on Amazon, $9.30. I need an arc generator. This is a supposedly 1,000 kilovolt high voltage powered generator. It's $11. I need a logic level N channel MOSFET, and that's a logic level on the gate that will trigger the MOSFET. These devices take quite a bit of amps, so get something a bit beefy. I need a nano. I need a linear power regulator, or at least I very much like one. And then another optional thing is a radio controller. When I deploy this at my house for real, I'm going to trigger it via my radio controller. I didn't include this as part of my build here because I've done that previously. Ah, geez. All right. So sorry about that. So yeah, I did already previously do the radio controller thing. I think it was last year. So come on. So I'm not going to cover that. So here's my show and tell though. So let me stop my screen share. Or sorry, stop my PowerPoint here. And let me pop open the code. That's not the code. Hang on while I open the code. Okay, so here's my code, and it's really dead simple. So I have 4 things here. I've got a button pin because I'm going to activate it with a push button. I've got a solenoid FET for the pneumatic actuator. I've got an arc generator FET, and I've got an LED. This is the built-in LED. I just wanted to see the LED to go on when I push the button. So my setup for Arduino, as I always tell people, I always delay 1 second at the startup. That's so if you get the serial jamming something out immediately, if you do that, you won't be able to program it. So if you give it a little bit of a delay first, you might be able to get the programmer to go before your program starts. I am setting the pin modes. So I have the button pin as an input with a pull up. And the reason I use the pull up is because when I put a button on there, the simplest thing for me to do with that button is simply ground out that pin. So if it's normally pulled high and then I ground it out, then it gets pulled low. So this internal pull up is really kind of helpful. One thing that I did run into as a problem is that I chose pin D13 because it was right next to my thing as the button pin. But D13 won't work with pull-ups because it's already got that LED and resistor on it. So even pulled up all the way, it only registers about 1.5 volts, which isn't enough to show it pulled up. So it never actually pulls all the way up. So instead I moved it to pin A1. For the solenoid FET, the arc generator FET, and LED FET, I just set these output, and then I'm setting their initial values in the setup here. So I want the button pin to be high, but all these others to be low. And then here's my main loop. Again, this is dead simple. I'm reading the button pin. I'm looking to see if it got pulled low. When it gets pulled low, I know that the button's being pressed because it's grounding it out. And then I just kind of have a little bit of debounce logic here, just so I probably don't need it in this case, but just so I have a little bit of debounce logic here, I delay just a little bit and I check to see if it's still up, or sorry, it's still pressed. If it is, then I get going. So I'm just serial print lining stuff here just for debugging purposes, but the very first thing I do is I set the LED pin high. Again, that's just kind of to show me that the thing is working. And then I turn the arc generator on high. I turn the solenoid on high. I let those go for about a second, and then I shut them down, and then I turn off my light. And that's all there is to the code. So at this point, I'm going to switch to my phone, and I'm going to go show you the circuit board and the thing, the actual Canon, and show it working. So give me a second to switch to that. Okay. It's showing the selfie video. I wonder if I can swap it to the other video. No, I guess not. Okay, selfie video it is. So let's go to the other room where this thing is.
We're working on the audio.
Do we have audio now? Sweet. Okay. Now, if someone could tell me how to switch this to the other video, really love that. Pardon? It's in one of the options. Thank you, Dan. Dan's a lifesaver. Okay, so here's my board. And so at the center here, you can see my Nano. And then I added that push button up here. And here's my two FETs that control the arc generator and the pneumatic valve. And this guy here is the linear power regulator. This takes this 12 volt input that I've got here. Thank you. And it makes sure that it gets just 5 volts to the Nano, anything else that needs that. And I've got this pigtail connected to it that I made, and it connects to this guy over here. So this is rotated anyway. This is the guy. So here I have mounted my arc generator. And what I did is I drilled a couple holes in the barrel, which you can just barely see. And these wires just poke right inside the ends of the holes. And the idea here is that there'll be an arc pulsing through here, and when the cotton ball goes through it, it'll ignite. And it's kind of something cool to watch. Will you push the button for me, Dan? Yeah. So if the flaming ball doesn't scare him, that should. And so yeah, this is just a pigtail for that. And then down here, I've got the valve in here. And I don't know how I made it to this long in life without realizing, but something you should know is when you go to Home Depot and you look for these couplers, they come in one of three flavors. There's industrial flavor, there's automotive flavor, and then there's a works with either flavor. Well, I bought a bunch of industrial couplers with automotive nipples, and I couldn't connect it. And that was kind of a pain, but got that worked out. And so let's see. I don't think there's much else to show. It's actually a pretty straightforward thing I've got here. So let's see it work. So the first thing I need to do is hook up the air. Okay. And next I need a piece of gun cotton. You gonna be a camera guy? It's better than shooting half a piece. And actually, before I shoot this, I'm going to show you another problem I had. So now I've got the air hooked up. When I push this button, you'll notice something that's interesting. The arc stops right as the air comes flowing out. And the reason is because it takes a bit of time and energy to get that arc established, and there's plasma that kind of going between the two. And I'm literally blowing it out with this airstream. So one thing I'm going to have to do is I'm going to have to move this clear to the back, and I'm going to have to ignite the cotton before I actually pop it out of the barrel. So in my demo here, I'm only putting the cotton slightly behind the arc, so it'll still ignite. It won't shoot as far, but it'll still work pretty good. Okay, so got a piece of cotton. I'm gonna fluff it up a little bit because it burns better. Stuff is pretty safe. It burns so rapidly that it doesn't have a chance to really ignite anything else. So I'm okay doing this indoors. So I'm just gonna tamp it in here just a tiny bit.
Not that we recommend doing this indoors.
Not that we recommend doing this indoors. Good point, Phil. All right. So it should land about here. All right. 3, 2, 1. Oh, ignite. One more time. One more time. Okay. 3, 2, 1. Third time's charm. Maybe I will just put it in the put it in the arc. Okay. 3, 2, 1. All right, so that's it. Have we any questions?
Do it again.
Do it again? Is that the question?
Yep, no question. Just do it again, please.
Sorry, repeat that one more time.
Yeah, could you do it again?
Yeah, I'll do it again. need my flame stamper. Park. Okay. 3, 2, 1.
That was awesome.
It'll throw a lot further when I change it around, but that's all I had time to do today. All right. Who's next?
Great. So I was hard up for ideas for this meeting, but we've had it. We've had this project on the back burner for quite a while now, and several years ago we all bought these little Tesla coil kits, and I thought it would be a cool idea to take these two Tesla coils, which happen to be singing Tesla coils, and make some scary Halloween speakers out of them to play spooky sounds or spooky music. And I didn't know how well they would work, so I set to putting one together and just see what I get. And I thought it would be fun to try and drive it from an Arduino, but we've kind of done that. So then I thought it would be kind of fun to drive it from a Pi, and that does work, but not the way that I wanted it to. So we'll do what we can here. So first and foremost, here's a picture of a Tesla coil. And if someone were to ask you to pick out a Tesla coil in a lineup, that's probably the one you would point to. So down here in the box, we have some circuitry and some robust components for doing what Tesla coils do. And then sticking up just on top of the box is very few large windings of a primary coil. And then you have this stick popping out the top. And that stick is a very fine secondary winding called a secondary coil. And on quintessential Tesla coil, you'll probably find this torus-shaped donut on the top. And that is called a top load. And I'm going to talk about what all of these things do, and then I'm going to talk about why mine is not actually a Tesla coil. Sound good? Great. So here is a schematic for a Tesla coil, and this is a Tesla coil as designed by Nikola Tesla. And it's as simple as it looks as far as the actual circuits, but it's very difficult to put components in here that are tuned well enough for the thing to work. But assuming that you do that, the way that this works is that, well, first let's talk about what the heck a Tesla coil does and what it is. A Tesla coil is a high voltage, high frequency AC power generator. So if you give it alternating current as the input, and you can do this off of 60 hertz mains power if you want, although you would probably want to use 220 instead of 110. But regular power from the wall will work. And this is just a transformer coil that they would start with. And then here in this primary circuit, there are really only two components that are doing the work. There's the capacitor here and the spark gap. And so what it'll do is the AC will sit there and oscillate back and forth from the first coil here, and it'll charge up this C1 capacitor. And when that capacitor has enough power to saturate and discharge, it'll discharge much more power than it's getting over the coil from the mains, and it's going to jump that spark gap. And when it does that, it's going to complete this circuit, and it's going to dump all of that power from this side of the second coil to this side of the second coil. And when it does that, the disparity in the windings here are going to cause a much greater voltage output, and you'll get a high voltage on the second coil. So the first circuit here is going to transform this into an oscillator, a high frequency oscillator, and the second part of the circuit is going to turn it into a high voltage generator. And between the two, what you end up with are some very cool, well, let me see if I've got things like this. This is a very high-powered Tesla coil, not the sort that most people have or most people can build, but the sort that I want for Christmas. So you can see on this one that he's got arcs that go all the way from the top of the torus to the ceiling, where it's finding its way to ground. And if you look very carefully, you may not see it, but there are little probes sticking out of the top load. And he's just doing that to get these arcs to come out of a singular point instead of arbitrary locations across the surface of the toroid. So the way that that's working is the, the, the primary coil here. I'll go back to a picture that we can view. The primary coil here is dumping that high voltage into the secondary coil, but the secondary coil has all of this energy now that it needs to do something with. And so there's one end of the coil at the bottom here is grounded hard and connected to the same ground as your mains probably. And the second end is just floating out in the air. And the idea behind that is it's really cool for these things to just arc out and find a ground and create these plasma waves in the air, similar to the ones that Nate was demonstrating in the end of his dragon tube. But with all of that energy, it becomes a little more interesting if you can store that energy and then discharge it in a more interesting way. And so the point of the toroid donut up here is this becomes what's called a capacitor. Early versions of it were called a Leyden jar or a Leyden jar. And this is going to store up an abundance of electrons on its surface while power is being dumped into the secondary coil. And when this thing finds a ground, a whole bunch of those can kind of jump all at once and discharge off of that. And it gives it a little bit more drama. So I'm going to take a minute to switch over to my phone. And let's see if I can share that.
Okay. Start back over.
All right. So the history of this project is thus. I went and bought a couple of kits, and they sat in a box in my basement for a while, and then I decided to do this for Nunag. So I pulled one out, and I had trouble getting it done last night. I couldn't find some things. So I came in today in the office to do it and realized as I'm asking some questions of the other two guys working here that have done this, one of them just got one sitting at home. So I didn't have to assemble it at all, but here's his. And so first I was going to show you the finished one. And there it sits. Ooh. And so here's the secondary coil, and you can see there's no toroid on it. If we were to build something like that, we might get more interesting effects. But here, I can barely even see it, but here is the end of that secondary coil. And just like the ones that we were showing in the picture, this is where that energy is going to jump right off. So that's where we're going to see the plasma. Here are some instructions that came with it. These are interesting. You can put these in Google Translate, the really cool app that you just pointed at it and it shows the correct translation right up top of it. And apparently these guys can't even write Chinese properly. So these are useless. The pictures are all that you can use it for. There is a schematic on the back. I meant to talk to you about this. I said that I would tell you why mine is not a proper Tesla coil. The schematic, as you can see, is much more complicated than a proper Tesla coil. And the reason for that is the primary and the secondary coils are actually linked in a controlled way in this schematic. And that means a couple of things. First, it's not as challenging to get the components tuned together to make it work. And second, you're not going to get as much power out of it. So these are really low power systems, and they're not nearly as dangerous as a Tesla coil, but they're really easy to build and really easy to design. And even though this is much more complicated than a Tesla coil schematic, this is not complicated by any means. I think there were only 10 components on this board that I soldered on. In fact, let's have a look at them. Because I bought two kits because I thought I wanted to use two of these at the same time to make stereo speakers. How clever is that? So I'll just dump them out. And this kit costs about $5. You get it on eBay from any number of sellers. The circuit board is printed. It was the best instructions in the whole lot because you can see where the resistors go. You can see where the positive lead on any of the polarized components go. The only trouble I had was I had to determine which resistors were 10K and which were 2K, and that's what my $3 meter is for.
Did they not have stripes?
They have stripes.
Okay.
It's just easier to put them on the meter. There's your secondary coil. Here's a cap. There are some standoffs and screws to go on the bottom. There are two transistors. One is a BJT type and one is an amp, we're pretty sure. and heat sinks to go with them. They're reasonable heat sinks. They get warm pretty fast. 2 pairs of resistors, some thermal gel for your transistors, 2 LEDs, and 1 electrolytic capacitor. This is your primary coil.
That's a coil. Looks like a piece of wire.
That's a coil. So as you can see, it just wraps around the bottom of the secondary coil, and it's just one winding, and that's all it needs because it's
like 390 degrees is all.
So this type of circuit is called a Slayer exciter. And even though I've been saying Tesla coil, I'm just keeping it simple. A Slayer exciter is the proper name for this type of generator. So I'll just leave these out for a second, put those away on my own time. And we'll come over here to one that I have hooked up to a Raspberry Pi. And Nate, don't get your phone too close to that because we don't know what it's doing. But
Trying to get the corona on the end there. I got it up against white background. It's working.
one other thing that it comes with is a neon bulb, which you might look at this and say, oh gosh, it's all mangled. And where the heck does this go on the circuit board? It doesn't go on the circuit board. This is the purpose of the neon bulb. It's just there to play with. So a neon bulb is unique in that there's no continuity between the anode and the cathode, and there's no filament. There's just an anode and a cathode in there, and they're not really even an anode and a cathode because these are polarity agnostic. But they have a closed chamber with neon gas in there, and if energy excites the neon gas, it'll flow. And if you run electricity between the two terminals, it'll excite the neon gas. But obviously, we're not hooking this up to any electrical source. I'm just sticking it in the field of the corona coming off the top end of the secondary coil. And it's generating enough voltage to excite that. And as I recall, when I was a kid, I learned that these require at least 90 volts to light them. So I assume there's at least 90 volts going through there. And I can do it from different angles, and you can kind of get a feel for where that field is, where it starts and where it ends and how thick it is. So this is a really cool thing that they include. So on my Raspberry Pi, I wanted to load up Sonic Pi. And if you're not familiar with Sonic Pi, it's a programming system where you can write program scripts to generate sounds and music. And if you're into programming and you're into sounds, this might be the coolest thing ever. And I haven't gotten into it too much other than to do some demos as an aside at some Raspberry Pi presentations. But they have some example scripts that you can pull up right here in the IDE, and I just pasted one in here. And this one is called Tron Bike. And it sounds kind of interesting, and it's kind of cool to listen to. And I didn't spend time digging through any other examples to see if there was a better one. I just tried to get the sound here working. And I have trouble getting sound out of a Raspberry Pi the way I want it to, because it has 3 different ways that I know of to get sound out of it. You can go through the HDMI, which was working fine, or you can go through the audio jack, which requires a friendly plug most of the time, but we do have a cable that works. Or you can use, go ahead and point to that. Yeah. Or you can use a USB sound device. This is just like a sound card. And this, I think we did get that working, didn't we? But so we did get all 3 of the sources working. The problem that we had was that Sonic Pi will only output out of the HDMI. So that kind of ruined my fun. Because the way that these coils generate sound, they probably work best with some very clean generated waves, as opposed to the noisy stuff you get in a recorded hit song. So because I was thwarted on this front, I thought the next best thing to do would be to go to the YouTubes and just find some synthesized types of sound. And the first thing I pulled up actually worked really well. And so it's on full volume, but I'm just gonna hit play and see if the phone will pick it up. I say I'll hit play.
Slow pipe.
Slow. I don't know if you can hear that.
It's cool to see that actually
Watch
dances
it
to
dance. Yeah.
the music.
The way that this is working is as energy jumps off of that top load, it's creating a plasma field, and that actually disrupts the air around it. And so if you send energy into the secondary coil in certain frequencies or in time with music, it will modulate it in the air. It will actually expand and contract the air around it to the beat of the music. There's a lot of hum to it too. I don't know how much of music it's picking up.
Do Super Mario. The 8-bit sound can come out really good with these.
Let's see. I can't even pause it. It's just so unresponsive. There we go.
Getting nice. It's hard to get it focused on something.
It might take a second to find something. That's what it's doing. So one of the things that I expect to work really well on this is if you were to set up a MIDI music source, a keyboard, or something, if you're just playing a MIDI file on the computer. Video game music, I think I expect to be just as good, depending on how well it's encoded on YouTube. So that comes out about the same, I think. Dan, can you hear that at all? Well, that's disappointing, but I'm deaf and I hear it just fine. It is faint, and you know, the cool factor of having this be your desktop speakers is not a reality.
Let me put my speaker towards it. Darn it.
That's too bad. But these are a fun thing to put together. You know, they'll entertain your nephews, and it's not unfun to put together. I do recommend you not touch the Corona.
How do you know that?
How do I know that? Well, I'll show you. If you were to be holding this from the power supply, that happens. And then when you go to lift that back up, the Corona is probably not in the best spot. That's how I know you don't want to touch the Corona. And these, they are hot. They're hot enough to fry an egg right now. So that's probably okay, but honestly, I think I should have a fan on.
That hot, huh?
It's really, really hot. Yeah. In fact, I might need to see a doctor. So that's about all I have. And it's going to be Dan's turn if he thinks he's got something, but it doesn't sound like, I think that's the end of our project. Do you have anything for us, Dan? Okay.
Well, do you want to show the 3D printed structure of yours?
Not in the best of states right now. So the idea is this is going to be a rehash, I guess, an update with the Orange County did a few years ago. One of my first Unos there. The idea, I can show you some stuff with this. Well, actually, it should be already. So right now I've only got running this bottom section. The idea is that there's a button here that I can show off the circuit in a second for. But when you hit it, you can see it's really quick because right now I'm not. I've got the animations done wrong. But you can see it does run animations a little bit. So once I get those set, things should be okay. But inside here, there's just a series of NeoPixels, which are they're LEDs that are based on so they're flat mounted LEDs They're the WS2802, I believe, chipset that's on. So they're individually addressable, which means I can control each LED that's in here. And then you can see I've just got a battery charger connected to a lithium-ion battery. And then I've got these pins, or these connectors that I've got that connects each one, and then this is the common ground for all of them. This is the same thing, it's just that this is the piece that goes from the wide piece down to about my wrist size. So the bigger piece is going to be here, shrinks down to my wrist, and then this piece is the arm cannon piece, which I tried to design a little bit like Mega Man's. In the front here, and then in the edge, there are round NeoPixel rings, and those will allow me to do animations to glow once I can figure out what I'm doing stupidly. And then I've got more strips just going lengthwise inside the actual hand. You can see right now it's extremely crowded because everything's kind of shoved in there while I'm trying to get everything to work. You wouldn't believe it, but this has taken me 3 days and it's not gotten any further. I made some similar mistakes like Nate did, trying to use the analog 6 and 7 pins as digital pins. That's not supported. Trying to read different things. Anyway, stupid things. So there's just a button that's connected to an Arduino Nano, which when you push, is just supposed to do the animations. Right now, I'm just not letting them hold long enough. And then, of course, I'm not doing anything. I'm just trying to get the animations to work. All through today, well, not all through today, but since work ended, I've been trying to get this thing to work. And at some point, somehow I ended up overloading the Nano to the point where it can only get 3 animations in, and it would just die. So I upgraded to a much more powerful Nano 33, and it would do exactly the same thing. So I don't know what I was doing, but I wiped out that code and just started from the basics, and now I can do this, which is a lot of progress. Obviously, it's just getting it to do simple stuff, so it's nothing that's terribly fancy. That you can see, if you look really quickly, that the LEDs do turn on in a circular motion. So once I get that working, then I can get everything to go. The idea inside here, there is actually a sound effects board that Ada provides. Now this is Nano. No, that's this one, right? No, the sound effects board is back here. Oh. So if you just look up Adafruit SFX, you'll be able to find the board. Where is it? This is the wrong spot for the one thing. You want to be on the arm cannon or the hand cannon. So you can see it, it's that giant circuit board in the back there. But anyway, the idea behind that board is that you can basically just ground out one of the pins, and based on how you name the files that are on it, it'll play some song. So if you have just one that's named T01 and you ground out pin 1, then it'll play that audio file until it gets to the end. If you were to name it T01 latch, and when you ground out the pin, it'll sit there and loop on that audio file until you ground out the pin again, and then it'll stop. There are things you can have it play one and then play the next and then play the next until it gets to the end of those. So it's a really smart chip and should make this really easy, but unfortunately I got caught up on doing these. So once I can get the animation working, then I can worry about getting the audio going, and then should work from there. It's really just a simple system. I can probably get the chip out here. Back here's the chip. So
it is a big guy.
That. And then I've got this piece here. So that's the audio. This here, so you can see I've got a speaker on this end, and then this is just an amp. So you just got your leads for the speaker, and then this just sits here on the header pin that I've got. And I should just take an audio signal from, make sure I get that on the right pin, from the soundboard and lead it in. You can kind of hear there was some humming for a second, but anyway, so that's that board. Again, I just ran out of time and can't figure out what I was doing wrong. And so
You have an audio board in your hand you wanted to share?
I have an audio board in my hand that I do not want to share. In our last meeting, for those who were with us, I said, hey, that's the same kind of board that I've got. And
They're not.
they're not. I would recommend his because A, it probably works, and B, mine certainly does not. Well, I don't know about certainly. I didn't get it to not work, but I got it out and decided today's the day I'm going to use it. And I went to go find docs, and there is nothing. I followed about 5 links in a row before I finally found a zip file to download with some docs, and it was an invalid zip file. And I said, enough of this crap. The only thing I did find was a guy on the web who said, it doesn't work anyway. It plays what it wants. It doesn't play what you do. So it tends to just play things in order rather than what you tell it to play.
That looks like a UART interface. Is that correct?
It's a UART interface. So you send it serial commands that are 1 byte long, and it ignores them and plays what it wants if it plays. This is about $6, which is actually on the expensive end for audio equipment for these little MP3 boards. And it has a little SD card slot on the bottom. And any microcontroller can drive this. I just don't think it's a very good deal. So I wanted to be clear about the kind that I have and the kind that he has. This is called a Catalex YX5300. And so that's the one to avoid. It seems to be really popular, and I seem to see a lot of people saying that they think they're great, but I don't know if any of these people are using them because there's no dock for it. So those are my thoughts.
I do believe we had a big argument about whose sound card was the best, and we all asserted that ours was. Do you want to show anything else here?
No, if I can get it plugged in, I might be able to show just shorting the pins real quick, but I would need your power supply and your pin.
You can have it.
Stuff. So let's want to stall for a couple minutes.
Sure, I can stall.
This is the DF Robotics one, right?
It looks like it, sure.
Yeah.
So what's neat about this one?
I got it to work.
What interfaces does it have?
I forget. It was like 5 years ago.
Well, if I remember correctly, it supports the pin thing like Dan's, and also
It supported multiple interfaces. I do know that when I was fiddling with it, I could jump one of the pins and just get it to play. So I think it had a play and a skip, and I think it had some, maybe it had some play by index pins, I forget. And I think I don't remember if it was SPI or if it was serial. But it works. It played what I wanted, and it would stop when I told it to, and it would tell me when it was done playing, and that's something no other board has done that I've used.
Well, I appreciate it's a lot more compact. It'd still be nice if they had silk screened on here what these pins were.
Well, it's better than that. It's also cheap. It was like $1.50. So the most expensive part about that is the SD card
And there's a lot of documentation.
and the documentation.
I built a little project with that one, and it worked really good. After Phil's presentation like 2 years ago, I got a couple of those and built a little box thing that played sound. It was pretty cool. It worked good.
I'm glad to hear that somebody's actually working with some of the knowledge you're gaining from some of the failures that we have here.
Mine worked good.
What was that, George?
I said, Phil's worked good, the one I saw that year, or whoever's it was that was using that MP3 module.
Cool. It says that worked really well. He used it.
Okay.
Do you have anything else to stall with? Okay. I really wish we could have heard the sound through the thing, but that's disappointing. All right, let's see if Dan's by chance ready or close to. This looks like fun. What you doing?
I'm just going to see if I can get this to load really fast.
I got some of that jiggly wire if you want.
Jiggly wire?
Yeah.
So I was thinking that, like, when we all do a project like this, what we really need is to gamify it somewhat, make it a competition.
Yeah, because we don't make it a competition anyway.
Yeah.
So I was thinking, maybe we send out a survey like who won.
Well, you can.
I
You're
like
just
it.
mad because I'm going to win.
I think your project went up in flames. Mine had victory music. Are you flipping me off?
No.
You don't think I'm funny?
Oh,
Do you
geez.
have more like these wires? You're
Yeah.
saying? Yeah, everything. Just
There's a couple of loose ones here.
put the.
Oh. Feel free to peel them off if you'd like. I also have some already peeled off if you'd like me to go get some of those.
I thought I looked at that.
Okay. So while you're waiting, what do you guys want to see next time? You have project ideas you're dying to see? One's gray, light gray.
Like in a year from now, or
Always take some jiggers.
Sorry, George, what was that?
project ideas from a year from now, or presentations for next month, or what was that question?
Well, both. I was thinking project is for, next time we do the Halloween gadgets, but if you have requests for next new nug, I'll hear those as well. Oh yeah, if you're going to volunteer, that works too.
I know I should one of these days, but the project I wanted to build was one I was thinking of this last week was a box where it would spray hand sanitizer on your hand and tell you it was going to deposit a goodie, but instead it sprayed your hand with glitter.
Nice. Hey, if you build it, we'll do a 7-3 for Halloween.
Good idea.
Did you hear his idea? It's kind of faint. He says, build a box that says you can spray your hands with sanitizer, but instead spray it with glitter.
Oh, that might be illegal.
Glitter is the herpes of the craft supplies.
What's it hit?
Right.
There's really.
What are the odds I can start all this stuff?
1 and 2.
I'll give you 3 to 4.
Down to 5 volts, shall we?
5 volts, 5 volts. That's a 30-volt supply.
Probably have something I can plug into. Come on. All right, if anybody sees any blue smoke, let me know.
Hold that.
Get over yourself. You're not the first person to light something on fire tonight.
On purpose or otherwise. I heard speaker go crunch.
On speaker. All right, so theoretically, what you guys do that for me? So we've got, you can see this is actually pretty well labeled. So the rightmost pin is voltage in, second is ground, and then on the left you can see that it's that L that it's currently plugged into. You're actually making it worse.
I'm not making it worse.
Yes, you are.
Fine.
It adjusts the light for the.
Yeah, I know. That's why I was going in slow.
Anyways, you can see the leftmost pin that's connected is that L. That's the left channel. There's also a pin for R, which you could do a second speaker for the right channel. All my sounds are mono sound though. And then this amp is similar, where you've got ground on the right, voltage in next to that, and then these last 2 pins are A plus and A minus, which is just the speaker. And in this case, the polarity for these does matter. So you need this to be the green one to be coming the one that's positive from the L, and then this can go to ground. But coming out of it doesn't necessarily matter. These kinds of speakers are usually universal. It just means that when you should be pushing air, it'll be pulling air, so the sound is actually backward, but your ear won't really be able to tell the difference. So I should be able to just ground out one of these pins. And I should have audio files for 0 and 1. Assuming I put that on a pin I can ground. Only that's the problem I've got, is that my audio files didn't work. Yeah, I'm gonna guess that's the problem. Sounds like random audio. It is. That's actually the audio that I uploaded, though. That's the Canon that I was sending to you earlier. So yeah, it sounds like I had maybe the gain too high. If I had a small screwdriver, this amp actually has a tiny little potentiometer right there. But so far, the only screwdriver I've been able to find that has it is those glasses. I know we have it here.
Can it not drive the speaker directly with some amount of sound?
It kind of can. There's 3, it shouldn't be 1. 4 shouldn't be 1. 5 shouldn't be 1. 6, 7. Yeah, so the rest of them, I don't know why 1's not playing. Maybe it's because I. Nope. Okay, yeah. Go ahead and reset that. So that is actually supposed to be the audio file, but apparently when I transferred it, then I just must have had the gain too high or something. So, but anyway, that's how it's supposed to work. It's just the Arduino, all it needs to do is just ground out one of those pins. So it just needs to take its pin and lower it to the ground, and it will trigger that. So sounds like I just need to upload the files again, just do some editing.
Okay, well, to end off, did you want to show the code that you wrote for the Canon?
I don't have anything worthwhile right now.
Okay.
You can, if you look at the Arduino NeoPixels, you can do multi-path NeoPixel, and basically that's all I've got so far is just what they've got. So nothing terribly fancy.
Okay. Okay, well, it sounds like we're done here. So thanks, everybody. Thanks, Dan, for hard work. Thanks, Bill.
About as well as it usually is.
And hopefully we'll see you guys next month and also next year.
Sounds good. Thanks for everything. You guys are awesome.
Thanks. That was really fun.
Thanks for coming.